Hello everyone. Today I am going to do a slope analysis here. For that you need to have a DEM file. You can get it from the USGS Google Earth Explorer, and today I am using 30M resolution SRTM DEM file downloaded from the Google Earth Explorer. Now I am going to add my DEM file here. I am adding my DEM. After this, you have to insert. First of all, you have to check your data is in correct projection or not. Otherwise, you might get error. So now I am inserting my area of interest here. Look at it carefully. Now I have to extract only my area of interest here. Now what I am going to doing is that I am drawing a extract by max, or we can do clip also. Get it here. Now you have to input your DEM file and which layer you want to max or clip out. You have to input that layer and you have to give a suitable output location and then click OK. Now with this you have to make it hollow so that you can be visible your area of interest. Now this is our raster image of our area of interest. Now you can remove it. With this we have to go through our different steps. So first of all, you have to get a contour. You have to develop a contour from it. Now you can just type contour on the search, then you can get it. Input raster from which you want to get your contour, and now you have to put a contour interval here. I am going to use nearly about 80 so that it looks clear. Now we doesn't have to add any other factor or any other base control. It is optional and you just have to click OK. Now you can see it. We have developed a contour line here. It develops. You can observe it by zooming. This is our contour line we developed in it. Now you have to create a tin, contour to tin, tin to raster, and then raster to slope. It is a 3D inline analyst tool. You have to give here output location. It doesn't matter where is it. Now I am assigning my coordinate system. Input class feature. I am going to add this and this, and I am doing it as it is. After adding this our area of interest, our output will be more focused or more it limits the tin output. You can see it here by just I will show you what it makes differ by adding an area of interest in it or skipping it or leaving it. It takes a time to load. Tin is triangulated irregular network. You can see it elevation range of the tin. It starts from 160 to 391 and then goes to up to 2239. With this, now we have to convert it into raster. Sorry, I typed wrong. Into raster. Again, you have to input your tin and you have to give it a raster. It is not the final output, so I am leaving it in the scratch file as a way of the ArcGIS. It will get erased from the system. Now okay, with this I'm clicking OK and running it. Now I'm removing this tin, unticking this tin and Control 2. Now this is our raster file from which we have to create a slope map. Now I'm going to run a slope tool here. You can see it. I'm gonna add my create in this one and slope. I leave it to it. It doesn't matter now. I'm just now you can see it. This is our slope map. Now we have to give a finishing touches so that it looks more clear, and we have to calculate the area of every portion. Yeah, I am unchecking all other extra output that we have developed to reach to the You can get it makes our output smooth. I am going with the bilinear interpolation. You can see it makes our map smooth and looks more attractive here. You can open. Now you have to reclassify it. According to your working location. That means up to how much altitude your work is efficient or valid. Make the criteria from below to up, so that it will define your most preferable zone attitude and altitude, then your moderate working zone. In this way you can calculate the high slope area. You can see it here. I am showing it. It is 0 to 3 degree slope, 3 to 10 degree, 10 to 18, 18 to 25, 25 to 32, 32 to 41. Now you can see it. Our area has maximum slope of 71 degree, up to 71 degree. Now I am adding my raster. I am going to classify it into in this way. I am going into it. You can get it. It will develop it into the 4 criteria. Now I am just clicking OK. This is our reclassified data, and now we have to convert it into the polygon, raster to polygon. Every reclassified part will convert into the polygon feature, and it helps us to classify our slope area. Now with this I am running raster to polygon slope. You can see it here, and I am leaving it here and clicking OK. Now you can see it here. This is our output, and you can see we have to make it Greek code. It will give us our Greek code, means this 1 2 3 4. This means Greek code 1 represent a slope area of 0 to 15, and then as we reclassify in our window, you can see it. This is, you have to assign it here 0 to 15. It makes easy. 15 to 30, 30 to 45, and you can write it here 45 above, or you can type just greater than 45. You have to click apply, and you can change your color ramp to. It will help, pretty sure. Now this is the ramp which I want. After this you can see Green zone is 0 to 15 and it is flat land. You can see it here. This is our slope map. Now we have to calculate the area. So what we have to do is that you have to develop a field here. First of all, add field, put it area, and make it float type. You can doing geometry. Yes, we have to get it in hectare. Now this is the area of the every Greek code, but what I am going to do is that I am going to merge select by attribute. You can get it Greek code equal to get unique value, do 1, then apply. Before that you have to do start editing on your final. That means this. Then click OK, continue. It doesn't matter. Now what you have to do is that you have to merge and click OK. It will give you 1. Only one area, only one portion that denoting Greek code value 1. You can see it here. I am going to delete this or turn off this. It might create confusion. So now I have to do similar for other 3 Greek code too. You have to get it unique value, apply, then you have to get merge and click OK. Similarly, you have to do 3, apply, merge. You are gonna merging your area denoted by the Greek code 3, and now this is our final Greek code, and this is our final merging step. Now you can get it. We have 4 Greek code, 1, 2, 3, 4. With this, now we gonna calculate we're gonna close this and we're gonna save it first, and we're gonna stop editing. Now I'm gonna add area field here. I'm going to calculate area in hectares, so I'm adding it hectare. I'm making it float. I'm clicking OK. I'm sorry. I'm going with this. Now you have to develop you can get it from here. You have to check your coordinate system and which property you want to get it from it. Now with this, I'm going to clicking just OK and clicking yes. You can get it our area here in hectare. And in this tutorial, I have a final slope map and you can get it into a layout format. You can get it and add your necessary item here according to your need. And with this we have done our slope map, and we have calculated area of every bit of Greek code, and this denotes that area covered by 0 to 15 slope degree slope area is this 1,76,246, and area covered by 15 to 30 degree slope is this, and we can get it from here. Now with this I am gonna end my video here. Thank you.